Okay, so we need the determinant of this to be equal to 0. You can use the trick where you replicate the first two columns on the outside and go that route. And I mean, you know me enough to know by now that that's not how I roll. I prefer cofactor expansion. This one, I mean, it looks like there's no two ways about it. It looks like we just gotta kind of dive in and go for it. Okay, so I'll work bottom row, I think. Something appealing about those coefficients. So 2 multiplied by -1, it's row 3, column 1, determinant of 4 to 5 minus lambda 2. Plus -2, -1, row 2, column 2, 5 minus lambda 2, 4, 2. Row 3, column 2, thank you. And then coefficient of 2 minus lambda, row 3, column 3. And then all the bells and whistles. 5 minus lambda, 4, 4, 5 minus lambda. Oh, I bracketed it for some reason. All right, even power, so positive number, so we'll have a coefficient of 2. You know, I'm just going to rewrite. You don't have to, obviously. -2 because of the odd power. 5 minus lambda, 2, 4, 2. Even power again. All right. We're looking at 8 minus 2 times 5 minus lambda minus 2 times, I'll just write it as 10 minus 2 lambda minus 8, which you can clean up on the fly if you want, plus 2 minus lambda multiplied by 5 minus lambda quantity squared minus 16. That calls for a double check. Signs are good there. Rewrote it correctly. That's always a challenge. 8 minus that. Good. Carried out multiplication correctly. Subtracted. Well, didn't subtract correctly. And I think we're good. Okay. Phew. So we got 8 minus 10 plus 2 lambda minus 2 times 2 minus 2 lambda which I guess I can clean up on the fly a little bit. Let's make this a, yeah, so this is going to be a -2, right? All right. There's some GCFs here, which aren't really going to help. It doesn't look like it. Now, bear in mind, at any point, now, also bear in mind this is correct, hopefully correct, but you can kick over to a calculator or whatever you're ready. Like if you don't want to, if you don't want to do the algebra, I'm not going to force you to do it. Okay, so that's completely your call. It would just be really super nice if there was a coefficient of 2 right there, because then this baby would clean up ever so nicely. Maybe not ever so nice, but relatively nice. Are these exact opposites? Unfortunately, I think they're exactly the same, which is not as nice, but we'll take it. So this is -4 times 2 minus 2 lambda. And I think I just got to do it. Just got to grin and bear it. The 25 minus 10 lambda plus lambda squared minus 16. -8 plus 8 lambda plus 2 minus lambda times lambda squared minus 10 lambda plus 9. Well, that is factorable, right? Let me see about that. Because I can pull out a -8 from the first guy and get a lambda minus 1. So we still got a little quadratic action going on here. Yeah, so maybe the directions on this one should be find the eigenvalues of the matrix, because I think it's a little too lengthy to then ask you to find the vectors that go along with them. -9 minus, wait, no. 2 lambda minus 18. Oh, purple. Minus lambda squared plus 9 lambda. Housekeeping. Start with the -8. Nope. -26. These two guys. And I got plus 7 lambda minus lambda squared. Is it 11? Yeah. Thank you. That helped me avoid the inevitable staring contest I was about to have with the problem when I couldn't figure out why 13 times 2 didn't add to 13 and 2 didn't add to 7. So anyway, negative lambda minus 1 lambda squared minus 11 lambda plus 26 although it's still not going to work, right? Well, with real numbers anyway. 26. They're not clean. I just want to kick over to the calculator real quick. Just take a look at the graphical solution, just going way back to the beginning here in the first purple line. See if we could have got some of this anyway. Because any rational zeros you should get definitely from this without doing all the algebra. That's the whole point. Not much of the incentive if you don't use it. And also, if we get a bunch of rational zeros, I'll know I screwed something up. So that's what I want to do now.
So on the test, do we just do this from like the get-go?
Yeah. Nah, not unless you enjoy algebra. I mean, even if you do enjoy algebra and you just don't want to do it on test. Yes. Oh, hello. Okay, so there's a mistake somewhere. Because I got a 0 at 10. I got a 0 at 1 and 10. Well, that just ran out. It's this number here. Because it looks like I have a double 0. Well, I definitely have a double 0 at 1. Because it has multiplicity 2. And I have a 10. So the factors here had to be x minus, or lambda minus 1, lambda minus 10. So this somehow should have been 10. Which means that that's probably supposed to be positive. not seeing it. So somebody will find it and they'll submit it and they'll get a bonus point for it. And that's just how it is. Right, so that should be a 10, right? So negative lambda minus 1. Oh, power of 2 missing. Lambda minus 1. Lambda minus 10. All equals 0 is what we need it to be, and so therefore lambda equals 1, multiplicity 2, and 10. All right, so, yeah, but again, I'm also changing it. This is a very lengthy problem, so we don't need the eigenvectors part of this. Oh, because the zeros, the x-intercepts were at 1 and 10. So they had to, since there was a multiplicity of 2 for the root of x equals 1, that means it had to be a double root. So I knew I had to have x minus 1 twice. And then the x equals 10 corresponds with a factor of x minus 10. So this trinomial had to factor to x minus 1, x minus 10. And the only way that would play out would be if that were a 10. All right, so yeah, another one I'll take is, hey, how about a little bit more room for number 5? That's probably a good idea, I guess.
I think I found a mistake. You factor out the -8. Didn't change the signs.
When I factored out this -8?
Yeah. I think. Yeah.
But I think I only factored out of these two terms, though.
Yeah, but you didn't change the sign.
Oh, but I didn't change the signs of that term.
Yeah, you just flipped it. You didn't change the signs.
Gotcha. Oh, I should pull that up instead of 8 then. Gotcha. And that's an it's a -10.
Yeah. But then you still have to factor out -1 later and switch it.
Oh, okay, gotcha. Number one mistake in all of math. And there it is. I think we know what the moral of the story is there. Just do it on the calculator, don't worry about it. Not something math teachers are overly known for saying, but that's me. And I'll take this up. And paste it down here somewhere. I'll worry about what it looks like later on. No, I just want to get it in. All right, so again,
A minus I lambda. So negative lambda, 1, 2, 2, 3 minus lambda, 0, 0, 4, 5 minus lambda. All right.
Again, always look for upper triangular, lower triangular, diagonal. Well, diagonal first. That's the one that stands out the most obvious, in the most obvious fashion. But we'll take triangular in any fashion as well. None of which are in play here, so that sucks. So yeah, cofactor expansion.
Let's see. Either the second or the third row, I think, are going to be okay. So 0 times whatever, irrelevant, plus 4 times negative 1, it's row 3, column 2. The matrix that results is negative lambda, 2, 2, 0. And then plus 5 minus lambda, negative 1 to the 3 plus 3, negative lambda 1, 2, 3 minus lambda. All right, so we're starting with a negative 4 here. Diagonal down is 0. Diagonal up is negative 4, so that's good news. Finally, something that cleans up off the bat a little, not terribly. This one has a positive, an even exponent, so it's going to give you a positive result. So we're looking at plus 5 minus lambda. Diagonal down is giving us negative lambda multiplied by 3 minus lambda. On the upswing, minus a 2. All right, so again, kick over to your calculator if you think it's gonna help.
If you don't like the calculator, if you don't know how to do it on the calculator, then it's not going to help, so don't do it. But if you do, then just type it right in and see where it gets you. All right, otherwise,
Start distributing, start cleaning up. Ideally, correctly. Some sort of balance between calculator and by hand is never necessarily a bad thing. Saw that in action in the last one. That's how I knew I screwed up. The lost art of the check.
all right. Again, you still got to follow, if you're going to do it algebraically, you got to follow appropriate rules of algebra. So, I'm only bringing this up because I've seen it in this class, in the last couple of assessments. Just some funky algebra when it comes up. Like an example of which is something like you get to a step like this. And let's make it even simpler. You have two binomials being multiplied. I've actually seen people subtract the constant from both sides and then set each of the factors equal to the constant. That's not a thing. That's not something you can do. For reasons why, I can put you in touch with a beginning algebra teacher.
Right. All wise-assery aside, it really is that elementary. Like,
it's the zero product property. You can set any factors equal to 0. You can't just set them equal to some constant. It's just not a thing. All right. So what this means is, unless the exception here is, if you have something that you could write in power form. So if you could write this as, let's say, lambda minus 2 to the third power, then you could bring the 16 over, take the cube root of both sides, and then go from there. But
aside from that, unfortunately, it means you're distributing. ideally correctly. So run through the 5. Oh, possibly. Yeah, negative lambda cubed. Hence the ideally. Plus 2 lambda equals 0. Alright, so we got a negative lambda cubed, that's this guy. Got some squared terms, so it's going to give me, what, an 8 lambda? So these are done. And I get a negative 13 lambda. These two guys, plus 6. Alright, again, perfectly acceptable to go to your calculator. So they're like, why do you keep doing this algebraically? Because I'm telling you, I say it over and over again. Doesn't matter what class I teach. I say you can do it on the calculator. Half the class is not going to do it on the calculator. I don't know why. But they don't know how to use rational root theorem, so it's like, well, then why aren't you doing it on the calculator? The answer, the short answer is because they think they can do it algebraically. When I'm going over it in class, realize after I've gone over it, oh, I didn't know how to do any of that. But I wasn't paying attention to how to do it on the calculator. So I guess I'll just have to figure out how to do it algebraically. So let me just, I really just need to kind of hook you on this. I got to sell you. For maybe there's only 2 of you now that are like, yeah, I'll just do it by hand. This is how you'd have to do it if you didn't want to do it on the calculator. List out your coefficients. I glossed over this previously. I mentioned rational root theorem, but we didn't really get into it. All right. What you'd have to do is identify all possible ratios of the constant term and the leading coefficient. All right. We call it the P over Q values, but it doesn't matter. All right. So you're looking at any number of possible factors that you can get once you divide this number by that number. Or, I'm sorry, divide any of the possible factors of this number by the factors of that one. If the leading coefficient is 1, then it's no big deal. You're just looking at possible factors of the last term. If the leading coefficient is something other than 1, now you're doubling, maybe even tripling the number of possibilities. But at this point, it's only limited to 1, 2, 3, and 6, or negative 1, 2, 3, and 6. Okay, so I'll start with 1. Again, this is, you don't want to use a calculator, so this is how we're doing it. You're not sold. If you get a 0 remainder, that means that the number that you selected is a root of that function. So we got lucky in the first try. That's great. And what's even better is that we went from a cubic to a quadratic. Now I can move away from this whole synthetic division stuff. If it wasn't a 1, if the 1 didn't give you a 0 remainder, then you try a negative 1. If that didn't work, you try the 2. If that didn't work, then you try a negative 2. If that didn't work, you try a 3 and a negative 3, 6, negative 6. And again, if the leading coefficient is something other than 1, then you start with 1/2, 3/2, negative 1/2. Spend the rest of your life on this problem. And also, bear in mind, because there's always somebody, when you screw up on the one that works, then you try all the other possibilities, and you write no solution, you get all pissed off. It's like, oh, how was I supposed to know that there was no solution? The answer was, well, how was I supposed to know that there was a solution? well, your calculator is how you're supposed to know that there was a solution. Oh, and also general knowledge of cubic functions, because cubic functions always cross the x-axis. It's just a question of, will it be a rational solution? This is a rational root theorem. So if the answer is a radical, it's not going to show up using this. So that's fun. Anyway, x squared minus 6x, oh, sorry, lambda squared. I just put myself firmly in pre-calc mode. I get fired up over this. Because when I tell people, use this, it's to your advantage, and then people don't, it's like, I fill in a backstory in my mind. Like, oh yeah, you think this is best for me? What do you know about me? I hate you. I'm not using your stupid technique. And so then I start getting resentful. And so use it. Not this, the calculator. This is terrible. Look at this. I mean, you get the answer. So now you have 3 eigenvalues. You know, they're not, 2 of them are not unique. We have the one that worked in synthetic division, and the 6 and the 1 that emerged from the factoring of the quadratic. Right? So I tend to put the mult2, the multiplicity of 2, to remind me that I'm going to need to have 2 vectors in my, well, if I were doing it, well, in this case it won't matter, but if I were doing a diagonal matrix, I would need to have 2 vectors for the eigenvalue of 1. Right, so that's an important thing. Right, now again, going back to the calculator, for those of you who are like, yeah, no way, I'm not doing the calculator. Calculator's stupid. Calculator's not stupid. It'll save you like 10 minutes of work on this. You have to do all this stuff, gets you to this line of work. I'll put a, we'll go smiley face on that one, for those keeping score at home. You can do some of the basic, like, there's no reason why you can't just make that a 16 plus 5 minus x, so we're using x, negative x, see, look at me, I'm getting mad at you for previous classes, for things that they've done. It's crazy. But you could just look at me right now. You can see how aggravated I was at them. By taking it out on you right now, I'm hoping to avoid the same outcome. All right, look at that. Look at that beautiful graph. I mean, you don't even need the whole graph. This part of it is sufficient. That's all you need. Good looking graph. All right, it looks like a parabola right at this location here. That's 1 multiplicity 2. This looks like a linear function. Linear functions have a multiplicity of 1, so that's, I guess I should count 1, 2, 3, 4, 6 multiplicity of 1. Your multiplicities should add to equal, not only the degree of your polynomial, but also the dimensions of your matrix. So you should account for all 3 of them. All right, so now I have my eigenvalues. Now I just have to come up with my eigenvectors. By doing that, you've avoided all of this, and you've taken a question that might be very lengthy, even though the one previous to this was a very lengthy question if you have to do the algebra. Not lengthy at all if you use a calculator. The question that I always get is, well, what if it's not a clean number? You know, what if I just can't count tick marks? Put in a 0. There's other ways to do it. Put in a 0. I like the intersect function. 0 for y2. Second trace 5. Find that intersection. First curve, second curve, guess. It'll drag you to an intersection. And in reality,
even if you're like, I don't know this whole multiplicity thing, I don't know what he's talking about there. Once you get the 6, even if you go down the route of synthetic division, now you know the number to put on the outside. Run through a synthetic division, you'll get a quadratic. That quadratic is going to factor to x minus 1, x minus 1. Now you have your double root of x equals 1. Right? So it all comes out in the wash. Right?
Most of you already knew all that stuff. Some of you, minimal experience with the graphing calculator coming into this course. Most everybody else is kind of somewhere in between, you know, a little bit of experience, maybe not an overwhelming amount, but these little tidbits, they're time savers. They're how you're going to finish the test on time, right? That it's so important. You get bogged down in this algebra, you're not going to finish. All right, so I don't need that. I need my characteristic matrix. So we have to address each of these eigenvalues. We have 6 and we have 1. So a minus 6i times x equals 0. And then we'll take care of, at some point down the line, a minus just plain old 1i, a minus I times x equals 0. Get my eigenvectors.
Now you got your characteristic matrix characteristic equation coming right up. All you have to do is replace the lambda with the 6, so it should be pretty easy.
You can jump right to the augmented matrix. Negative 6, 1, 2, 0, 2, negative 3, 0, 0, 0, 4, negative 1, 0. I'm going to need a little space below that, so. No, I'm just going to do it on my handheld. It'll be a little quicker. One thing you're going to see in your sleep when this course is over is me typing in matrices just to hit ref. Which is still better than actually doing it all by hand, I think. Barely. Math enter. Alright, so I got 1, 0, negative 3/8, 0, 0, 1, negative 1/4. Also, well, always ending in 0, so. Alright, so we're looking at, these are all x3 measures, those non-zero quantities, so we're looking at x equals, I'll show the intermediate stuff, I don't want to, I was just going to jump right to the final. So x1 equals 3/8 x3, x2 equals 1/4 x3, with x3 equaling x3. And so then x would be equal to 3/8, yeah, but after I write the x3. Alright, so that's that one. The next one just has a bunch of ones plugged in, so negative 1, 1, 2, 2, 2, 0, 0, 4, 3.
Okay, 044.
044, yeah, I'll get that in a sec. Thanks. So 1, 0, negative 1, 0, 1, 1, 0, 0, 0. And so we're looking at x1 equals x3, x2 equals negative x3, x3 equals itself, making x equal to x3, 1, negative 1. All right. 7. This is where we kind of deviate a little bit, because if you look at number 8, it's kind of like a precursor, really more of a general variation on number 7. Then you can kind of see where it's going. All right, so I mean, the one good thing is 2 by 2 matrix, so the determinant itself. Okay. Minus a negative product, 0.6 times 0.75. I'll just run the calculations real quick. 0.1 times 0.5. Oh. Say it again? Oh, thank you. I'll just make it look a little nicer. So that's going to change. Oh, yeah. Well, the second part will be the same, but I have to move it over, so. .5 minus lambda, 1.1 minus lambda, plus 0.6 times 0.75. All right, so that was a fun one. So 0.55 is the product of 1.1 and 0.5. And outer is negative 0.5 lambda minus 1.1 lambda plus lambda squared plus 0.6 times 0.75, 0.45. Alright, so lambda squared, negative 0.6, negative 1.6. Yeah. And then plus 1. Barring anything too terrible. Okay, so that's going to be equal to 0. So complete the square quadratic formula. So if I complete the square, I'm just taking my b value, cutting it in half, and squaring it, adding it to both sides. So we're adding a 0.64. So lambda squared minus 0.8 squared on the left and then negative 0.36 on the right. So then we'd have to take the square root of this bad boy. So imaginary unit I to address the negative, and then the square root of 0.36 is 0.6, right? Yeah. So plus or minus 0.6i. Oh, sorry, that should be a lambda on the inside of my binomial. So lambda minus 0.8 equals plus or minus 0.6i, making lambda equal to 0.8 plus or minus 0.6i. So we have two eigenvalues, two complex eigenvalues. All right, and so you can write them separately. All right. So another case where I didn't really give an overwhelming amount of space. All right, well, I'm just going to keep going. Move this out of the way. So if lambda is equal to 0.8 minus 0.6, just pop it right in. We're looking at 0.5 minus 0.8 minus 0.6i, negative 0.6, 0.75, and then 1.1 minus 0.8 minus 0.6i. It's a little messier, but it's no more complicated conceptually. It's just not overly nice to look at. So negative 0.3 plus 0.6i, negative 0.6, 0.75, positive 0.3 plus 0.6i. All right, so what we would have to do at this point is row reduce. Notice, I've actually never tried this. It's weird. I thought I've tried everything with my calculator. I thought I knew everything. I've actually never tried it with a complex number before, which is strange. No time like the present. Why not, right? Just make sure your calculator is in A plus BI mode so that it understands that sort of thing. So go to mode, and then instead of having it in real, make it A plus BI. If it's going to work, it would need to have that setting. If it doesn't work, then I'll show you how to do it by hand. The I button, if you didn't know, is second decimal point. Data type, okay. I'm just going to make sure I typed it in reasonably. Yeah, it's not accepting it. It would have been nice. Now you know how to put your calculator in A plus BI mode. Alright, so I want to get this into reduced row echelon form, so I need to get rid of that, make that a 1. Or I can make that a 1, doesn't make a difference. I'll make that a 1. Because eventually we're going to have to address the elephant in the room. So why not, right? So we can divide out. Do we want to divide it out? Well, we might as well just do it. So I need this 0.75 to go away. It's already negative to start, so that's good. So 0.75 over, actually that's just the leading coefficient there. It could still work, but just want a good plan of attack here. I think maybe I'll go the other way. Let me just do it. So I need that to go away. That's going to cancel to a 1. So I need it to be a negative 0.75. Okay, well, not ideal. So I'll go to a 0. And then the next entry is going to be what did you say? Negative 1. Positive 45. Plus 0.3 plus 0.6i. So then we need to get a common denominator. So 0.45. So then we're looking at plus first term to be what, 0.09, negative 0.09. Put it in parentheses. Outers and inners are going to cancel out. Plus 0.36i squared. All right, so we got a point. Well,
Here, this is going to be 0.36, right? And then that's going to be a negative 0.36. So the whole shebang is going to zero out. Which is, I mean, the word shocking doesn't apply, I don't think, directly, but it's not necessarily what you were expecting. It seemed like it was going to get much more disastrous. So then the next and final step would be to divide row 1 by negative 0.3 plus 0.6i. So 1 over multiplied by R1. So 1, and then we'll have negative 0.6 over negative 0.3 plus 0.6i. Now that you should actually be able to do on the calculator if you want. I mean, you don't, like I said, you don't have to ever. Because you'd have to multiply by a conjugate, simplify, multiply by a conjugate, if you really wanted to attempt to clean it up. But if you have your calculator in A plus BI mode, and it is something that can be simplified, the calculator will be able to handle it. It's just it didn't understand it in the context of a matrix. So, we can math bracket if we want. So we get that 2/5 plus 4/5 I. So x1 would be equal to negative all this stuff. Where x2 is equal to x2. And so therefore, x would be equal to x2 multiplied by negative 2/5 plus 4/5 I, distributed if you want, and 1. Now I know it scrolls down like a mile, but it does follow the model where you have the I component 1, and then the other one would have 1 and then the I component. And so I'll come back in a sec, but I mean it's here. Okay, so it's just following that general model. All right, and the other part works the same way. So not fun.